Today we are going to discuss the topic equilibrium of rigid bodies in two dimensions. Equilibrium of rigid bodies in two dimension is used to find the unknown forces and also used to find the forces, reaction and supports. Two conditions should be satisfied for a rigid body to be in equilibrium in 2D. The first condition is the summation of fx is equal to 0, and the second condition is summation of fy is equal to 0. Summation of fx is equal to 0 is force acting along x-axis. The sum of force are acting the sum of all forces acting along x-axis or the horizontal. Yeah. Next, summation of Fy is equal to 0 represents sum of all forces acting along y-axis. Then the second condition is moment about A is equal to 0. Moment about A means moment about any axis. A is any axis or plane. Sum of moment of any axis or plane is should be equal to 0. The formula for moment is F is equal to M is equal to F dot D. F is represented as the force applied and D is represented as the perpendicular distance from the axis of rotation to the line of space of forces. Step There are four steps to find the unknown forces. The step one is to draw a free body diagram. In that free body diagram, we should mark all the forces, including the point of application and direction. And then the step 2 is to choose the reference frame. The reference frame x and y axis you should choose. Then you should choose the step 3, set the equations of equilibrium. We should set the summation of fx is equal to 0, in which direction it should be positive, in which direction it should be negative. Like that you should check. Same goes to summation of fy is equal to 0, and the same goes to moment about any other is equal to 0. Then the step 4 is to solve for unknowns. We can solve for unknowns in two different ways. First is use algebra to solve the equation simultaneously, or include conditions of for both forces and moment balance. There are key assumptions in 2D equilibrium. The body should be rigid. The We should assume that the body is rigid. That means no deformation should be taking place. Then force acting in the plane is 2D. 2D analysis should be assumed. We should assume the negligible effects of air resistance or friction unless specified. Now we are going to discuss an example problem. Determine the tension in the cable and the question. Yes, the question is determine the tension in the cable and the horizontal and vertical components of reaction of a pin A, and the pulley is frictionless. Here they are mentioned that the pulley is frictionless. Okay, then then a diagram is given. In the diagram we can see there is a frictionless pinch or hinge. When it is placed, there are two unknown forces. One will go upwards in horizontal direction and one will go rightwards in vertical direction. Then there is a pulley here. The cable which goes through the pulley has same tension at both the ends, and a triangle is given to find the angle, and the one external force is mentioned at the point C, and the direct distances between some of the either is given. First, we should draw the free body diagram. This is the free body diagram for that object. Since the uh, 1T tension is lightly slighted, we should find the angle, and it is splitted into its components. One is t sin theta, and another one is t cos theta, and another end is t. Near the hinge, we have two forces. One goes upwards in vertical direction, and another goes rightwards in horizontal direction. Okay. Next, we should find the angle. To find the angle, first we should find the horizontal hypo. Now we should find the hypotenuse of the right angle triangle. For that, we have a formula: h square is equal to opposite square plus adjacent square. When we carry that square to another side, it will become root, and we found that the h value is 5 mm. Now we should find cos theta. We know that cos theta is equal to adjacent by hypotenuse. So it is equal to 4 by 5. Next we know that sin theta is equal to opposite by hypotenuse. Now we know that sin theta is equal to 3 by 5. Next we are going to solve for unknowns. First we take the equation summation of fx is equal to 0. In this, in the free body diagram, the forces which are acting in x-axis or horizontally which are acting, the forces we should take. If it moves rightwards, then we should take it as positive, and if it moves leftwards, then we should take it as negative. So minus t, which means the t is traveling in, the t is going in left side horizontally, so we are taking it as negative, and t sin theta, this is also moving in negative direction horizontally. So we are taking this also as negative. Then we are taking 100 n. The force is mentioned 100 n, and the force is moving horizontally rightwards. So we are taking it as positive, and ax is also moving rightwards horizontally. So we are taking it as positive. Keeping the ax this side and uh, carrying all that to another side will end up in this equation, and we consider this as equation number 1. Then we should take the second equation, that is summation of fy is equal to 0. Here the forces which travel upward vertically is positive, and the forces which travel downward vertically are